Hi, I'm Brian from Simply Brian Enterprises and welcome to my channel. In today's video, we're going to be looking at the homework solution for TopTechBoy's Raspberry Pi Pico series, lesson number 17. In this lesson, we're going to be taking some of the things we've learned with LEDs so far and take it up a notch by adding a push button switch to control it. So if we take a look at the hardware, you can see that I have my RGB LED still connected from the last few lessons, but I've added a push button. And this push button is connecting ground to a lead that goes to an input pin on the Pico. Now, before we get too deep into this, I want to talk about this little resistor right here. This is what we call either a pull-up or a pull-down resistor. And there were some questions that were raised about the purpose of this resistor. And I thought I would do just a little bit of code here to show you the importance of having a pull-down or pull-up resistor. Right now, what we have is called a floating pin. We have absolutely nothing going in or out of the pin. It's just kind of sitting there. And what's happening is it's picking up interference from everything else on the board, from the Pico, etc. And what we're going to see here is we're actually going to get some random values. So all this program is doing is just reading the value and printing it to the screen. We're not interacting with it anyway. We're not pushing any buttons. We're just letting the pin kind of tell us what it sees. And you can see very quickly we're going up to 58,000. We're going to go, we started at like 8,000, went up to 50,000. Now we're kind of crawling back again. Now we're at 2,400, 64. You can see that the numbers are just all over the place. If I were to take these values and write them to an LED, we would basically just see it flickering and we wouldn't get a result that we were actually wanting. So of course I wrote a little program to do just that. I'm just reading the input of this floating pin and then outputting it to an LED. And we can see as it runs that as we get kind of these unusual numbers, we can see that the LED is just kind of flittering about as the number increases and decreases. We're going to get a lot of flickering and we're not controlling this LED in any way. So if we want to have something like a push button to control it and tell that LED what to do, we are unable to do that. So the purpose of these pull-up and pull-down resistors is to give the pin a reference voltage to give it a more accurate reading. So what I'm doing here is I'm taking a 10K ohm resistor. There's a little bit of discussion about what size resistor to use. Universally, a 10K ohm seems to be a good choice. And what I'm going to do is I'm first going to plug it into the ground rail. And that's going to give me what's called a pull down resistor. Now I'm pulling this down to ground, so I should get a nice stable reference voltage that is close to 0. So if I run my little LED program again, you can see that we're getting a nice stable reference voltage right about 500 or so. The LED is just barely on. That's what we would expect from a pin that's pulled down. Now we can go the opposite direction. We can actually go and do a pull up. And by doing a pull up, I'm going to take to the 3.3 volt rail into the input pin through the 10K ohm resistor. So now I'm going to get a much higher value. I'm going to get something that's closer to a full on. And if I run that program, you'll see that's exactly what I get. I get somewhere in the range of 64,000, and obviously the LED is very bright. But notice whether it's low or high, notice the LED, the output of the LED is quite stable. Now, let's take that a little bit farther and let's introduce our push button. So what we're going to do is, let me flip back to my hardware view. I've got my LED bringing the port high, so I've got that high 64,000 value. I've got the push button that when I press that, it's going to bring the pin to 0. So if we, actually I think it was this program, sorry, I lost my way. So now I can run this and bear with me. And now when I press this button, notice that it turns off because it's basically it's basically taking the input pin to ground. And you can see I'm getting very small values while I'm holding the button down. And if I release it, the light comes on. And if I press it, it goes down again. Now, if you're watching really closely, you can see that there is a little bit of light coming from that LED. And the way we work around that is in this next program, I have more or less the same program, but what I'm doing is when I'm reading in the value, I'm inverting it. So I'm taking the high value, subtracting it from the maximum value, which is 65,535, subtracting my value, and that basically gives me the inverse of it. So if the input is a high value, meaning that the button is not pressed, it's going to convert it to a low value. If it's a low value, meaning the button is pressed, it's going to convert it to a high value. And then to get rid of that extra kind of almost off, but just a little bit dim, I'm setting this low value of 2000 to filter that out. So here we go. Now I'm running and you can see we're below that 2000 threshold. And when I press the button, the light comes on. And we have ourselves a nice little momentary circuit. I press the button, the light comes on. I release the button, the light goes off. If you remember back to our very first lessons with Morse code, we can actually send a little bit of Morse code. Let's see if I do this right. All right, if you caught that, leave it in the comments below. But it's kind of a nice little way of just having a momentary circuit, press the button, light the light. Now that is not what our assignment was. Our assignment was not to press a button and light the light. Our assignment was to press the button down, release it, and the light stays on until we press the button and release it again. Now there's really two types of push buttons when we talk about physical switches, and these are the type that come in the Kepler kit. Let's see if I can get that on camera. It's a little, let me try this a little differently here. There we go. So this is the type that comes in the Kepler kit, and this is what's called a momentary push button. So we press down, it makes contact, we release it, it lets go. There's a second type of switch called a push on, push off, or a latching switch. And the type of switch there, when you press down on it, there's a little clip inside that holds it down until you press it again and it releases it. Well, the challenge we have is the Kepler kit does not have a push on, push off type switch. So we need to, through code, convert a momentary switch to a push on, push off, otherwise known as a latching switch. So this is what we would consider a momentary program, where we hold the button down, the light goes on until we release it. We want to go to something called a latching program. And so as I walk through this code, basically what we're doing is we're taking my input and output pins, and I'm setting them up, instead of using the ADC and PWM, I'm setting them up as a digital input and a digital output. Because I have the pull down resistor on here, or pull up, sorry, because I have the pull up resistor on here, I can treat this as a digital input. Even though it can read ADC, I can treat it as digital. Now, when I have the button that goes down and back up, I need to track the state of the LED, because we're going to basically have a circuit that says, when I press this button, I'm going to flip. I'm going to invert the value, because we have a 1 or a 0 coming to the LED. If it's a 1, I want to flip it to a 0. If it's a 0, I want to flip it to a 1. So we're going to come down here into the while true loop. And the first thing we're going to do is we're going to read the value of the button. I learned the hard way that Python is much, much, much faster than I am. And so in order to get a clean reading off of this switch, I have to put a tiny little pause in here. 50 milliseconds is fine. But without this, the program does not execute properly because the code runs too fast. So I have to actually slow it down. And 50 milliseconds isn't really noticeable, and it does the job nicely. Then what I have to do here is I have to wait for the condition of the button to be false. Now, this pin is going to read true because it's pulled high. When I press the button, the pin is going to read false or low. So I'm going to wait for that state change. And then again, I'm going to put a 50 millisecond pause in here just to slow the program down so it gets a clean read off of the switch. And then I'm going to head into this while loop. So what I'm going to do, when I press the button down, it reads false. It does this 50 millisecond sleep, which is faster than I can go. And while I'm holding it down, it's going to go into this loop, and it's not going to do anything other than continue reading the value, and it's going to remain false until I release the button. Once I release the button, it's going to make a state change. So it's going to say the current state is going to be the opposite of the last state. And then it's going to output the state change to the screen, and then it's going to store the last state. So I'll show you when I run the program here. And then as its final step, before it heads back through the loop, it actually writes the value to the LED. So as I run this program, what are my states right now? My button is true, my LED is false or 0. If I hold down the button, I'm now in this loop of false, waiting for the release. When I release the button, now the button is true, the LED state is true, and the last state is 0 or false. Now when I press and hold again, when I release the button, it's going to invert the state of the LED again from true to false. And every time I do that, it's just going to keep alternating back and forth because I stored the old value in last state, the new value in current state, and every time through the loop, I'm writing the status to the LED. This way I can avoid the flickering because the state change is not changing rapidly enough that it would cause a flicker of the LED. It's only going to change once, and then it's going to wait for the button press to change again. So I hope that was interesting. A good explanation of push buttons, input pins, pull up and pull down resistors, and really looking forward to our next lesson where we're going to take this to the next level. And I hope to see you there. So if you like this video, be sure to hit like and subscribe below. For Simply Brian Enterprises, this is Brian, and thank you for watching.